5.2, you are given the Cartesian plane with the terminal arms OT and OP, and the coordinates of T it's negative 5, 8, and then P is 3, 4. The first question there, you are asked to find the value of A, which is the y coordinate, at T. That means you need to complete the right angle triangle with the x-axis, and then we know that negative 5 is the x coordinate, which is negative, is the x coordinate, which tells us that our x is negative 5 along the x-axis there, and then our y is A, and then the terminal arm is stayed in units. So that's basically a right angle triangle. So to find A, we use Pythagoras theorem. So we are saying A squared plus negative 5 squared should give us 13 squared, and that is Pythagoras theorem. Now our A squared will be equal to 169, that is 13 squared. Negative 5 squared is 25, and then if we bring to the right side, it becomes negative 25. That is A squared is equal to 144. Therefore, A is equal to plus or minus 12. That's the square root of 144. Now check whether A should be positive or negative. Now we can see that it's above the x-axis where y is positive. So we are saying our A is positive 12 because of also the quadrant. Alright, now that is 5.2.1. 5.2.2, you are asked to find the length of OP, which is the terminal arm. We use the same approach. We complete the right angle triangle with the x-axis. This is our x, this is our y. That means from the origin to the point vertically below P, that tells us it's 3 units, and then along the y-axis it's 4 units. So if you still remember the 3, 4, 5, you can actually tell that OP is 5 units, or else you will have to use Pythagoras theorem. That's the advantage of knowing some of these things. You can avoid wasting time. Alright, then that's 5.2.2. 5.2.3, the question requires you to find the ratio of sine beta minus theta. Now the question here is not about the size of beta or the size of theta. It is about the ratio of this angle. So to make things easy, we can expand, because this is a compound angle, that is sine beta cos theta minus cos beta sin theta. And then from our triangles, our sine beta, which is opposite over hypotenuse. Remember our A is 12, so that is 12 over 13. By cos theta, we come to this one, which is adjacent over hypotenuse, which is 3 over 5. And then minus cos beta, which is negative 5 over 13, sin theta, which is 4 over 5. So that will be 36 over, that will be 5, 15, 65. And then the negative becomes positive, that will be 20 over 65, of which you can also use the calculator, which is basically 56 over 65. If you can reduce it, you can further reduce it like that. Alright, then the last question on 5.2 is 5.24, where you are asking to find the value of cos 2 theta. And cos 2 theta is a compound identity. We know that there are three versions which we can write this. So what is important is that in this question you can choose any you want. Maybe you choose 2 cos squared theta minus 1, and then cos theta, we already know that it's adjacent over hypotenuse, that is 3 over 5, so we do the substitution, 2 by 3 over 5. Remember, when we say cos squared theta is the same as cos theta squared. So we are squaring what cos theta is, which is 3 over 5 minus 1. So that will be 2 by 9 over 25 minus 1, and then multiplying by 2, that is 18 over 25 minus 1, which will give us negative 7 over 25. So that's basically how you were supposed to collect marks as far as 5.2 is concerned.